Hi, everyone, and welcome to my talk about scaling GraphQL beyond a backend for front-end. Let's go to the next slide. Here we go. All right, so this is a talk about scaling a GraphQL API. We're going to be talking about how a GraphQL API might mature after a year or two in production. And I'm going to be telling you a story about a GraphQL BFF that I built with my team at Conde Nast and what happened to it. OK, so I want to talk about this because I think that at this point in GraphQL's popularity, there are other teams around the world who have built GraphQL BFFs and are wondering what to do with them next. So I'm going to be talking about the evolution of our architecture and the challenges that we experienced. So here's what I'm going to be talking about. First of all, what is a BFF? Secondly, how and why we built one. How and why we scaled it. Where we're going to go with that. And ultimately, what we learned from this entire process. So who am I? I'm Michelle. That is a photo of me. I work at Conde Nast in London. I have a very confusing Australian-British accent. But I was born in Fremont, so I feel like I'm local, you know. If you want to tweet me about GraphQL BFFs, you can do so right there. So what is a BFF? You might already know, but I'm going to tell you. So BFF stands for Backend for Frontend. It's a software design pattern for internal APIs that was popularized by SoundCloud. And by internal API, I'm talking about an API that is internal to an organization, rather than published as a third-party API for the public to use. And I want to talk about the model that the BFF design pattern is offering an alternative to. So the most common alternative to a backend for frontend is the one-size-fits-all API. It's a monolithic API that is shared between multiple applications or front ends inside of an organization. It probably wraps the main data sources that are used by applications in that company. And it might look like this, where you have multiple different applications sharing the same API. These applications might have different user experiences or use different parts of that shared API. But because it's a one-size-fits-all API, it needs to serve all of these clients equally. It is often a monolith, and it's the common denominator between all of these platforms. So it's not necessarily a bad idea to share an API between applications, but there are some common pain points in this scenario, especially if you're using REST. Firstly, different clients need different sets of data, and it's almost impossible for a one-size-fits-all API to serve all of these different needs. It cannot provide the perfect endpoint for every client, and if it tries, the monolith is probably going to become quite unruly. So the shared API also becomes a bottleneck when trying to roll out new features. Every time a new feature is required, the front-end team has to coordinate with the API team, which is responsible for the API. And that API team might have to balance the priorities of multiple different clients, and your feature request might not be the top of that list. This is where the backend for front-end pattern comes in. In order to solve the pain points of having one API and many consumers, the BFF pattern recommends building one API per user experience or per client. So that means each front end has its own custom API that is built and maintained by the same team as the front end. So it might look like this. A BFF is created as an interface between each client and a shared API or data source. That BFF implements API logic that is specific to that particular client. It's essentially a translation layer that transforms the data into a way that specifically suits the needs of that UI. Clients might be using multiple APIs, in which case the BFF would act as a kind of API gateway defined for a single application. It'll perform the task of aggregating and combining the data from a set of APIs into a common format that is convenient for that client. So what are the benefits of this? Firstly, it's easier to adapt your backend for front-end API as UI requirements change. As a front-end developer, instead of waiting for the API team to implement your new set of data or set up a new endpoint, you can just go ahead and do that yourself. It also simplifies the process of lining up server and client releases. Now that one team manages both the UI and the API, there's no longer coordination that has to take place between the front end and the back end team. Thirdly, because this BFF is focused on the needs of one application, it's inevitably going to be smaller and more manageable than a shared one-size-fits-all API. It's going to be easier to understand and navigate and probably have smaller payloads. And finally, you're able to aggregate multiple calls to downstream APIs into a single call to the BFF, which is simpler and probably more performant. So you might be thinking that a lot of those benefits sound familiar to you as GraphQL enthusiasts. The BFF pattern was created before GraphQL, but as you might be thinking, a lot of the benefits that I just mentioned actually come for free with GraphQL. For example, just as a BFF provides only the data needed by a client, GraphQL allows clients the flexibility to define their own data needs. Both the BFF pattern and GraphQL address the problem of overfetching from an API, and both the BFF and GraphQL allow you to aggregate multiple data sources into a single interface for the application. So there's definitely a lot of shared ground between GraphQL and the BFF pattern, but GraphQL is not equivalent to a BFF API. Backend for frontend is a design pattern that might leverage either REST or GraphQL, and not all GraphQL APIs are designed as BFFs. But I do think that because of this shared ground between the two concepts, GraphQL is a natural fit for building a BFF API in 2019. And in my experience, it's also quite common. So I've heard of many teams introducing GraphQL to their company or project in the form of a BFF. The BFF will often wrap legacy APIs, aggregate multiple data sources, ease the transition to microservices, or help with migrations between APIs. And I think that a BFF is a low-stakes way to introduce GraphQL to an organization. This is because its surface area is limited to just one application, and it does not require you to actually rewrite any of the downstream APIs themselves in GraphQL. So it's a good way to try out GraphQL and experiment with it. So I'm going to tell you about the GraphQL BFF that I built with my team at Conde Nast. I'll tell you where we started out, and later on I'll tell you where this API has ended up after a year or two in production. If you have a GraphQL BFF and you're wondering what to do with it, hopefully some of this will resonate with you. But first, some context. I work for Conde Nast, which, if you've never heard of it before, is a publishing company. We publish some magazine brands that you've probably heard of, such as Vogue and GQ. And GQ is not a magazine about GraphQL. Fact. Although I am lobbying. So for 3 years, I've been working on the team that builds the international websites for Vogue and GQ magazine, which are all served by a single platform. And these sites are currently fully powered by a GraphQL API in production 100% and have been since early 2018. Most of the content for our websites comes from an internally built content management system called Copilot. Copilot has a REST API that allows you to request data for content such as articles, galleries, etc. And of course, our websites use this REST API. Before GraphQL, our API architecture, in a very simplified diagram, used to look like this. So our web application, which is written in React, used to speak pretty much directly to multiple REST APIs, the most important being the REST API for our CMS, Copilot. Early last year, we introduced GraphQL to our project in the form of a BFF API. We wrapped all of the REST APIs that we used in a GraphQL layer that our React application now queries directly. We introduced GraphQL to solve many of the same problems that everyone else has introduced GraphQL for, but the most important impact of it was that it vastly improved the happiness of pretty much all the developers that worked in our code base. It gave us a single interface to fetch data for our UI, even though we use multiple downstream APIs. And now we could seamlessly combine content data with data from some other APIs like recommendations or configuration. And honestly, it was pretty joyous, and we were very pleased. It took us about 3 months to switch fully over to GraphQL. We integrated our new BFF API incrementally, literally switching over the data source page by page. So we started with a category page and ended up with the home page. And that was about 3 months. And how did we feel about this? Well, we loved our new GraphQL API. It was a really successful development in our architecture that made everyone working in the code base really happy. And it encouraged us to clean up a lot of our tech debt. Actually, we started censoring the word GraphQL in our product demos because we kept talking about it so much that everyone was so sick of us talking about GraphQL. But just to foreshadow the next section of my talk, I will say that we always had a slight feeling that someday the schema that we had built might be useful beyond the confines of just our application. And so we kept this in the back of our mind as we were designing our initial schema. So I want to stop here and talk about one of the most common concerns with BFFs, which is duplication. Already there's some risk of duplication in the BFF situation that I've just described, because we're essentially re-implementing a shared content API in GraphQL. So if another team wrapped the same API in GraphQL, or if they built their own BFF, then our BFFs would look pretty similar. And as developers, we are naturally adverse to duplication. We're obsessed, sometimes to a fault, with making everything as dry as possible. So for many of us, the BFF pattern might feel counterintuitive. But duplication is inherent to the BFF pattern. So Sam Newman, who wrote an iconic blog post about the BFF pattern, he has this to say about duplication. One of the concerns of having a single BFF per user interface is that you can end up with lots of duplication between the BFFs themselves. They may end up performing the same types of aggregation or have the same or similar code for interfacing with downstream services. Some people react to this by wanting to merge these back together and have a general purpose aggregating edge API service. But this model has proven time and time again to lead to highly bloated code with multiple concerns squashed together. And now to be more philosophical, I really like this quote from Sandy Metz: "Duplication is cheaper than the wrong abstraction." I believe that when we design code and services, we should always start from a place of duplication wherever possible and optimize later down the line once we've validated the actual need for a particular abstraction. And I'm talking about this philosophy because on our GraphQL BFF journey, we did ultimately create an abstraction that was trying to fix some of the duplication that was inherent to our BFF. But I don't suggest you do this without really questioning first if your abstraction is really necessary or if it is the right one. Don't create a shared microservice before you need one or before you're sure that that is the correct microservice to build. So with this in mind, I'm going to talk about how we scaled our API at Conde Nast. So when the question came up earlier this year of what was next for our GraphQL architecture, we had been using our GraphQL API in production for just over a year. We were using our API to power a platform serving 18 different websites in 9 countries across the world, and our GraphQL API serves around 200 million users each month, which is a very big number. So when we first introduced GraphQL, we were kind of rebels. Even just in 2018, GraphQL was not as popular as it is now. What we were doing was considered experimental, and we really had to prove the technical value of what we were doing. Internally, we had to fight against the perception that we were introducing a new technology for vanity reasons that didn't deliver any actual business value. But now in 2019, it's a very different world. We've had our API very successfully in production for over a year, and GraphQL is increasing in popularity. Every developer wants to work with a GraphQL API. And we started hearing from other engineering teams at Condé that they were thinking of introducing GraphQL to their projects. So we'd wrapped the REST content API that we used in GraphQL, and we had spent a year designing a schema that we loved and enjoyed using and validating it in production and iterating on it. And it seemed a shame to keep this to ourselves. Other teams within the business were still using the REST API that we had found difficult to work with. And then there was even another team that was building their own GraphQL wrapper around the exact same REST API, producing an eerily similar schema. So with this in mind, it came time to think about actually abstracting out the part of our BFF that would be useful to other people. So this is the change that we made to our architecture. So we decided to split our API into two, a core content API and the BFF. So it was clear to us that the content-related fields in our schema would be useful to other teams. So we decided to create our own core content API, making GraphQL first-class citizen for anyone using the content management system and needing to get data from it. We'd already written a schema and resolvers to wrap this API, but now we wanted to make this available for other teams to use as well. But we still felt like there was a need for the BFF, because the core content API could not serve all of the API needs of our React application alone. There are some parts of our schema that are not content-related, and they're kind of specific to our application. Some things like configuration and integrations with some other third-party APIs. And so we decided that resolvers for this part of the schema would remain inside the BFF for now. A big part of this dream was that we would be consuming GraphQL all the way down. So instead of carrying the complexity of wrapping a REST content API inside of our BFF, we could actually just consume pure organic GraphQL direct from the source all the way down. And here's what our architecture looked like before we split the content API into its own GraphQL service. And here's the change that took place. Now our GraphQL BFF will actually consume a GraphQL content API directly. And the logic required to wrap that REST API is therefore moved into its own microservice, and the BFF will just consume GraphQL. That GraphQL microservice can now be used by other applications in place of the REST API. It's now been elevated to the status of being a published GraphQL API for the content management system itself. So splitting out part of our BFF into its own microservice was a challenge all of its own. And as a developer, it is a rare opportunity that you're given the time and space to really improve on something that you've already built. And the challenge this time around was to take the schema that we'd already used in production and make sure it was generic enough that it could be used by other applications. And although this new GraphQL microservice is representing pretty much the same content data as what was in the BFF, we now have the license to make improvements with hindsight in mind. We can take all the learnings and pain points of using our schema in production for over a year and actually build something better to be used by other people and clean up all that tech debt. So now for the final challenge, which is to integrate this new and improved content API back into the production application. So as a reminder, here's what our application architecture looks like. The GraphQL content API, although it may replace parts of the BFF schema, the BFF is still the GraphQL point of entry for our application. So there's still data from other sources that's represented in the BFF. So all queries still have to go through the BFF. And here's what we want in order to integrate with this new microservice. We need a way to forward or proxy content queries through to our new content API via the BFF layer. And because we need to do this with as little impact to our production websites as possible, we need the ability to integrate with this new API incrementally. So we have a couple of options. The first, of course, is Apollo Federation. And we think Federation is very exciting, and we really want to use it. But when we started prototyping with it, we realized that it would probably suit us better if we were already working with a gateway architecture, which is not really where we're at right now while we still have the BFF schema. We don't have a clean-cut model of microservices that can be aggregated into a single gateway. What we do have is a bit of a hodgepodge of different REST and GraphQL APIs that are only aggregated for a single application. Our content API is also for use by other teams, so we can't just selfishly federate it into our own gateway. So we think we need to make a few more architectural shifts before we can use federation, but we would like to get there soon and use it at some point. Schema stitching is a little more minimal, maybe more along the lines of what we need in the immediate term, but the API is being deprecated, and we don't really want to invest too much in this paradigm. We'd rather just go all out with federation. So what we ultimately went with for our first pass at this was schema delegation, which is sort of halfway to schema stitching, where queries are proxied through, but we don't actually merge out schemas. So in this diagram, you'll see the content GraphQL Microservice is a remote schema, and we delegate all content queries that are made to our BFF schema through to this microservice to be resolved. And this option is a little messy for various reasons, but this approach got us forwarding our content queries through to our new API with minimal effort and minimal code changes. We're also able to do it iteratively, switching over to the new content API type by type. We really wanted a low-key way to get started querying this new API without having to re-architect any further. So we're thinking of it as an MVP approach that we're going to evolve and ultimately replace with something better. So what's next beyond MVP? So thinking back to what I said earlier about the similarities between GraphQL and the backend for frontend pattern, here's what I think now about BFFs and GraphQL. GraphQL is not a like-for-like replacement for a BFF, but I think that it solves enough of the same problems that if you evolve your architecture towards consuming pure GraphQL microservices, you might find that you no longer actually need a BFF. So with that in mind, personally, I'd really love to see our architecture move towards more of a gateway model. Once we've finished integrating and validating our first GraphQL microservice, I'd like us to gradually split out more areas of our BFF schema and convert these into services. So the REST recommendations API that we wrap could become a GraphQL recommendation service, and the same with configuration and so on. I'd ultimately like to get to a point where we could remove the existing BFF and speak directly to a single universal Conde Nast data graph. And if we have the ability to get all of our application data via pure GraphQL from a single endpoint, there's no need to keep our BFF. I think it's going to be useful while we convert the wider organization to building APIs GraphQL first, but ultimately, I think we will grow out of this pattern. I don't want to rush this process. I want to be as thoughtful as possible about how we scale our GraphQL architecture, and I'd like to continue validating all of our abstractions before we make them. So what did I learn throughout this whole process? First of all, I really believe in focusing on incremental change. People keep talking about this today, and I really believe in this. We've done this throughout our entire journey with GraphQL. And you may dream of having a gorgeous GraphQL gateway of microservices, but if you're evolving the architecture of a production application, you really need to start smaller. A big bang release is risky, and if you build something for too long in isolation, then you might build the wrong thing. Think about smaller areas of your schema that you can optimize or pull out as a microservice before you re-architect everything. And related to this, don't optimize too early. We could have built our content API as a generic organization-wide API in the first place, but we built it first just for our application. And I think that that ultimately made it a better API, because by the time that we went to design a replacement for the REST API, we had a year of learnings and product experience to inform us. We were also able to take more risks in that process because we didn't yet have the burden of supporting other clients with a published API where we'd have to maintain breaking changes. Premature optimization really slows down a project. It lessens your ability to be agile and respond to change. So before you go to build your ultimate perfect schema, think about using it for just one application first. And that's all I have. There are so many other challenges that I would love to chat about, but I don't have the time. So if you want to come chat to me about your GraphQL BFF, I would love to hear all about it. And that's all. Thanks for having me.